versus the quality of the reconstructed signal. Okay? Now, in a lot of practical applications, we cannot afford to stay here because the bitrate is just way too high. For example, video. It's almost impossible to do any reasonable amount of video compression with just lossless techniques. Okay? We were forced to use lossy techniques in order to support the type of bandwidth that we have. Okay? So let me first start by saying that you see image and video everywhere in our everyday life. Okay? Just take a look around you and you will see. The most primitive images that you see is probably the one coming from your fax machine. Okay? The transmission of binary images. Okay? Mostly for documents, right? We fax somebody a document. So it is an image, but it has only two values. It's either black or it's white. Okay? And that's how you read the text out. Okay? It wasn't designed for natural photographic images. Okay? And then if you take the next step up, we will have a lot of digital cameras that I'm sure a lot of you have. Okay? Which capture still images. Okay? So it's not moving images. If you want moving images, you go to digital camcorders. Okay? Some of the digital cameras also has video capturing capability, right? But it's not as involved as the digital camcorders. So these are video sequences with maybe audio signal tagging along. Okay. Now you have digital television broadcasting. Okay. We have digital video discs or digital versatile discs, right? The DVDs that we watch pretty much every day. I don't know if Vietnam has a lot of these. Personal video recorder. Have you heard of them before? It's basically a device that allows you to record, okay, digital images and videos, mostly digital videos. When you watch television, supposedly you're watching the World Cup, and in the middle of a match, okay, your boyfriend or girlfriend calls, okay, you have to. So this will allow you to not only store, but you can pause. Okay, pause the video in real time, and then after that play back. Okay, so this is very popular nowadays in the U.S., and I think it's going to enter the Vietnamese market pretty soon. Well, once we have a lot of digital television broadcasting channels. Okay, now the images that you see every day on the World Wide Web, okay, comes from the topics that we'll be discussing in the next 4 days. Okay, video streaming over the web. You played with them before. Okay, Apple's okay, Real Networks and Microsoft are the three major players in that field. Streaming video, right? Video conferencing. Okay, that is a subset of video streaming, okay, that allows you to do conferencing over a communication channel using video, not only audio, but so it's a generalization of a regular telephone call, right? Not only you hear the voices on the other end, you also see the images and the videos, okay? Now, recently we have a lot of image video capability on cell phones and Palm Pilots and portable devices as well. So that's going to be another market that will be exploding in the near future. Another hot topic is high definition televisions. Okay, this is really high resolution, high quality images and videos. Okay, and I already saw some HD TVs, I guess yesterday in Franklin Plaza. So maybe we don't have the broadcast to go along with it. Okay, but the capability is there. Okay, certainly you can buy HD TV if you want, it is a waste of money now because you don't have the content to display. You don't have nice quality signals to play on. But eventually we'll get there, right? Even in the U.S., it's only starting. It's not mainstream yet. Now, away from all these mainly entertainment business, we have very practical applications based on images and videos. Okay, I list a lot of entertainment stuff because it's very popular and it's very easy to see on our everyday life. But there's another branch, for example, medical imaging that hospitals use every day. They have X-ray, MRI, ultrasound, and they might even have telemedicine. Okay, so certainly these are qualified as images and video signal as well. And then we have military applications. Okay, you have multispectral satellite, infrared, microwave images that the military uses. Mainly, maybe the U.S. military, right? They're very advanced in these type of topics. There's a lot of money being poured into research for military imaging. Okay, so now the Westerner has a saying that's very popular. A picture is worth 1,000 words. Okay, so and let's try to explore really quick to see if it's actually true. Okay, so let's see. The size of a typical color image, okay, for display on your regular computers. And some of these images we will play around with today in MATLAB. 640 pixels across, 480 pixels vertically, right? And so you multiply them and then you have all those pixels. Each of the pixels has 3 colors, and if each of the color you use 8 bits, then you have 24 bits per pixel, right? Multiply them out, you have 92,160 bytes. Okay, so now that's a regular images that we usually see on the web. Okay, but now if you take your digital cameras, your mainstream digital cameras, roughly around 4 or 5 megapixels level. Okay, you multiply these out, so the resolution will be a lot higher than this, right? So same thing, 2,560 by 1920. Okay, multiplied by 24 bits, you actually have, let's see, 14 gig. Okay, roughly. Okay, now that's and let's take a look at an average word. Okay, for Vietnamese, I don't know, 4 or 5 characters, right? 4 or 5 characters per word, roughly, right? And suppose that you use 7 bits, that's ASCII, right? That's what we're using nowadays on our computers. 7 bits per character, you multiply everything out. So each word is about 4 bytes. Okay? Now 1,000 of them is only 4,000 bytes. Okay? So that's not 14 gig and that's not 92 megabytes. Okay? So an image is actually worth a lot more than 1,000 words. It's like millions and billions of words to be able to describe an image. That tells you how data intensive it is. Okay? It's not. So we're talking about 2-dimensional, 3-dimensional data that has huge bandwidth. And of course, if you don't have compression, we're gonna get stuck forever. Okay, images will not be able to travel on the web. You will not be able to email your friends your images, right? Nothing is gonna go if we keep the raw bit rate and this is only images, right? Now for video, suppose that we have raw digital video in DVD format. Okay, 720 by 480. That's the resolution of 1 frame. Okay, you multiply by 24. Why 24?